All right, here we go, kiddos. This is assignment 5C. This is the first derivative test. Um, this is what the first derivative test is. I'll show you what this means on this problem right here. So, um, so find the intervals where this is increasing and decreasing. So we obviously see just by looking at the picture that it's increasing from negative infinity to -1, all right? And it's decreasing from -1 to infinity. Now, how can I do this using calculus? All right, so first we need to identify any quote-unquote weird things, weird spots of this graph, and that is going to be any critical values. Again, what a critical value is where the derivative is equal to 0 or where it's like undefined or something like that, where it does not exist. All right? Like those are the weird things. Like, so where is the derivative equal to 0 or undefined? So we first find all of those. So here we go. So we take the derivative of this. So this is going to be -2x plus 1 to the 1 times 1 with the chain rule. All right? So -2x minus 2. Actually, no, I can make it just like this. And so I'm going to find critical values, and I see that I have a critical value at -1. All right, so what I do is I take this and I kind of put it on a number line of all possible x's, and I put them in chronological order, so the only important x that I'm talking about is -1. Now, I'm going to take a look at the derivative. Again, the derivative is the slope of the graph. Okay, it's the slope. And so what I'm going to do is I'm going to test a number over here and over here. So any number less than -1, so like -2, for instance, I'm going to put that into my derivative. So again, into the derivative, not the original equation. And I see that that is a positive number. Okay, it'll be 0 at -1. And now I go to a number that is bigger than -1, such as like the number 0. Again, I put that in my derivative, and I get an answer that is negative. All right, so again, what a derivative is the slope of the graph. So because this first answer is positive, that means because the derivative is positive, that means f, the original function f, is increasing. And then here, because it's negative, the slope is negative, that means f is decreasing. So let's kind of formalize this. Where is this increasing? Well, it's increasing from negative infinity to -1. Where is this decreasing? This is decreasing from -1 to infinity. Okay, so let's do this again. So the derivative, we're looking for critical numbers. This is going to be 3/4 x squared minus 3. Okay, where is this equal to 0? So this would be +3 times 4 divided by 3. So 4 is equal to x squared. X is equal to plus and minus 2. Okay, so I found critical numbers. Okay, those are my critical numbers. And so what I do is I put them on that number line. So my x's, so I have -2, and I also have +2. And what I'm doing is I'm taking a look at the derivative. So when it's less than -2, like -3, for instance, I put that into the derivative. And I see that the answer is positive. Any number between -2 and 2, such as the number 0, And I see that that answer is negative. Any number bigger than 2. And I see that that is positive. So what that is telling me is this graph, whatever it is increasing from negative infinity to negative 2, and also from positive 2 to infinity. It is decreasing from negative 2 to 2. And if you take a look at the picture, that is absolutely true. So it's increasing from negative infinity to negative 2, and also 2 to infinity. It's decreasing from negative 2 to 2. Okay, so again, critical values are where the derivative is equal to 0 or where things are undefined. All right, so right now, I see that x cannot be equal to negative 1. Okay, let's see that right now. Let's take a derivative. And so that is going to be what? Negative 2x plus 1 to the negative 3. So this would be negative 2x plus 1 to the third. So again, this won't be equal to 0, but x can't be equal to negative 1. So it's never equal to 0, but I still get a critical number at where these derivatives are undefined. So negative 1 is a critical point. All right, let's put it on the line here. Okay, so again, I test any number less than negative 1, and I put that into the derivative. It's negative 2x plus 1 to the negative 3. And I get a positive number. Any number bigger than negative 1, such as the number 0. Put that in my derivative, and I get a negative number. All right, so what this is saying is this is increasing from negative infinity to negative 1, and this is decreasing from negative 1 to infinity. All right. So again, where is this stuff increasing and decreasing? So I'm going to get a common denominator. So I'm going to multiply this side, both numerator and denominator, by the square root. So notice how the square root will go away in that numerator. All right. So what are critical values? All right, let me minimize this just a little bit. So we have two things that might throw us off the track, and that is we could get denominators of 0, which are not okay, but they're still critical values, and you can also get this thing equal to 0, which is just determined purely by the numerator. All right. So denominators equal to 0 would be when 16 minus x squared is equal to 0. And so this is the x is equal to plus or minus 4. So x can't be equal to plus or minus 4. Okay, that are some critical values. Other critical values is when negative 2x squared plus 16 is equal to 0. And so that would be when x squared is equal to 8, aka x is plus or minus square root of 8. Those are also critical values. All right. So x and the derivative. So we have, I don't even know what the value of square root of 8 is. Yeah, 2.8 something, something, something. All right, so we have negative 4, we have the negative root 8, we have the positive root 8, and we have positive 4. Again, root 8 is approximately 2.8 something. 2.8 something, something, something. Okay. So testing these out, let's test a really small number, smaller than negative 4, like negative 5. Putting this into the derivative, so the derivative is negative 2x squared plus 16 divided by the square root of 16 minus x squared. Oh, okay. All right, I ran into this last time. Also, a square root can't have a negative on the inside. So that isolates this domain right here to x has to be between negative 4 and 4. Okay? Because the inside can't be a negative. So, but putting that as a bottom 0, that means it has to be between negative 4 and 4. There is no graph outside of negative 4 and 4. So this has a restricted domain. It's had a restricted domain. And I'll show you how to handle that. So even though plus and minus 4 are critical values, they can't be equal to negative 4 and 4. So my number line goes from negative 4 to 4. And then we have this, the square root of 8s. All right. All right, so I can't test it. That's fine. All right, so let's go with a number a little in between the negative root 8 and the negative root 4, like negative 3. That's in between the two. And now let's put that into the derivative. So that's negative 2x squared plus 16 divided by the square root of 16 minus x squared. Okay, negative number. So in between the two, like a 0. It's a positive. bigger than a root 8, less than a 4, like a 3, is a negative. Okay, let me get a little bit more room here. Scooch all that over here. You're just getting critical values. Just delete this and get the idea. Provide enough room on this assignment. Sorry for the super micro print here. All right, here we go. Answer time. So that means this is increasing from negative root 8 to root 8. This is decreasing from negative 4 to negative root 8, and from root 8 to 4. All right, here we go. Hopefully this one's a little bit easier. So the derivative is cosine x. So where is that equal to 0? Let's bring in this. Cosine is the x value. So where is cosine equal to 0? Right there, which is at pi over 2. And right down here, which is 3 pi over 2. So I'm getting critical numbers of pi over 2 and 3 pi over 2. And those are all the critical values from 0 to 2 pi. So, putting this to good use, we have x and we have the derivative. And so this hypothetically starts at 0 and hypothetically goes to 2 pi, so don't go outside that. That's the domain that they establish. And so the numbers that we're testing are pi over 2 and 3 pi over 2. Getting kind of a rough idea what these numbers actually are. This is 1.57-ish. And this is 4.7-ish. And 2 pi is 6 something? 6.2? Right. So just kind of keeping those in mind. So now I can properly test this thing. So between the 0 and the pi over 2, like 1, I'm putting this into my derivative, which is just straight up cosine. It's positive. Pi over 2 to 3 pi over 2, this should be a negative. So like 2. This should be a negative. Three pi over 2 to 2 pi should be a positive. Again, just using the unit circle. Positive. Okay, so this is increasing from 0 to pi over 2, as well as 3 pi over 2 to 2 pi. This is decreasing from pi over 2 to 3 pi over 2. All right, now, this is what the first derivative test is really going to get you. Now that we know how to identify where things are increasing and decreasing, all right, so let's start with that. So we take the derivative. Right, so I see that important stuff is occurring at 3. All right, so identify all critical numbers. So here I have a critical number at 3. Okay, let's find where this stuff is increasing and decreasing. So we put this on the f and the derivative, and we have important stuff occurring at 3. So putting that into the derivative, when I throw in a small number, such as 0, I get a negative answer. Throw in a big number, such as 4, I get a positive answer. And so what I see as this thing is increasing from 3 to infinity and decreasing from negative infinity to 3. All right. It's all fine and dandy. Now, let's go ahead and learn what this is saying to us. Here's what the first derivative test is all about. It's not really to find where stuff is increasing and decreasing. It's to better understand this. That wasn't working. All right. So think of a graph. So you may recall that on a graph, when you have a max or a min, the derivative is going to be equal to 0. All right, so that's what we began with things, is where derivatives are equal to 0. We found those things. And here we have an idea of we're going to have one of these things occurring when x is equal to 3. When x is equal to 3, I'm bumping into something important happening. All right? Now, so I know that something important is happening at x is equal to 3. And it's most likely a maximum or a minimum, a relative max or a min. But which one is it? Is it a relative max or is it a relative min? Well, that's where the first derivative test comes into play. Let's take a look at the slopes that lead up to that 3 and go away from that 3. Okay, notice that the slopes leading up to 3 are decreasing. And the slopes going away from 3 are increasing. So what does that say about the 3 itself? That tells me that that is a relative minimum. That's a relative minimum. So again, kind of back to my number line here, it's decreasing and then increasing. That's indicating that it's a minimum. All right, so use the first derivative test to identify all relative extrema. All right, so I know that's a minimum. Now all that's left is to identify what is the actual point. So what is the y-coordinate of that? And so here I go back all the way to my original equation, and I see that x squared minus 6x is equal to -9. So what did I tell through all this testing? I know that there is at least a relative minimum, at the point 3, -9. We didn't test for absoluteness, so this is just a relative. Okay, here we go. Derivative. Better than that. So it's increasing leading up to it and decreasing. So what that is saying is if it's increasing and then going to a decrease, that is obviously a maximum. So we're going to have a maximum here. Again, when they get these multiple critical numbers, make sure you put them in order, like chronological order. So, for instance, the -2 comes before the +1, kind of idea. All right. So again, what this is this is increasing, increasing to a decreasing to an increasing. Okay, this is occurring at -2, and this is occurring at +1. So -2 is a max, +1 is a min. Okay, the derivative of h of the function h is continuous and has exactly 2 zeros. And notice how they exactly 2 zeros. So it's not switching across the x-axis somewhere in between here because we know where those 2 zeros are. So it doesn't do something like that we don't know about because it only has 2 zeros. Okay, so the derivative only has 2 zeros. That's important. And we know where they are, apparently. And so what I notice is here, you can kind of think of it like this. Where are the zeros? Where are, when you have derivatives of 0, you have critical numbers. And so I see that I have critical numbers at -1 and +3. All right? Now, what's occurring, below -1? Well, I see that the derivative has positive values. Between has negative values. and then I don't know what's occurring above the 3. I really don't know. So if the domain of H is set for all real numbers, then H is decreasing on which of the intervals? So it's at least decreasing from -1 to 3.